Hello everyone, my name is Derek Estrada, a student researcher, and together with my fellow team members from Samar National School, Mr. Franco Nube and Mr. June Albert Habuli, we will be presenting to you our research proposal as the representatives of the Catbalogan City Division for the Regional Science, Technology and Mathematics Fair under the Robotics and Intelligent Machines category. Our research is named Blind Sentry, a sensory glove for the visually impaired, which aims to develop a smart glove as an alternative to traditional blind sticks, and at the same time provide the lack of accessibility to assistive technology in our locale at an affordable cost. So the content of our presentation will include all of the things you need to know in order to get a good understanding of what our research will be all about, namely the introduction, the rationale, the scientific or the statistical basis, and lastly, the methodology.
Living in such a technological world as today is unquestionably a blessing to humanity, as it has led to numerous breakthroughs that have made our lives easier and more convenient. Modern technology has helped us immensely, particularly in the fields of healthcare and medicine. It has changed the lives of many that suffer from physical disabilities, such as people who suffer from visual impairments like blindness and other eye conditions.
Even with the progress of modern technology-dependent devices that aid the visually impaired population in most progressive countries, there are still a lot of persons with visual impairments who use traditional navigating devices. This is because our community is still economically behind other progressive cities in the country, and that the majority of highly efficient assistive technology products are scarce and are sold at relatively high prices in our locale.
According to the research conducted by the Department of Health back in 2017, there are over 2 million people nationwide who are said to be suffering from blindness and other visual impairments. An estimated 332,150 people in the country are said to be suffering from bilateral blindness, with cases of cataract accounting for 33%, which is approximately 109,619 of the total population. Errors of refraction accounting for 25%, worth 83,037, and glaucoma accounting for 14%, or 46,501. The DOH has also reported that the number of people suffering from bilateral low vision sits at around 2,179,733. Huge numbers, right? These numbers cannot be ignored because they indicate that our country has a relatively large population of people who are struggling with medical eye conditions, and these conditions can refrain them from achieving their maximum potential in life. Hence, these given statistics are the reason behind the proposal of this research study. The research study will need to determine the effect of the fixed alarm distance on the number of intercepted objects on the different setups. Thus, the researchers aim to measure the following variables upon conducting the research: the average number of obstacles evaded in different settings in terms of alerting distances, which is either 30 centimeters, 50 centimeters, and 80 centimeters. The optimal safety distance between the user and the object of interception among the three different distance settings. Wherein the controlled variable will be the simulated setting, the independent variable will be the adjusted alerting distance, and the dependent variable will be the number of objects intercepted.
This research study will be conducted using the true experimental quantitative design, since the effect of one variable on another variable is expected to be measured. And since the fixed alarm distance of the device can be manipulated by the researchers, it allows the number of intercepted objects to be dependent on the alarming distance. Thus, the utilizing of the true experimental quantitative design is justified.
On conducting the study, there will be different setups in terms of fixed alarm distances, namely 30 centimeters, 50 centimeters, and 80 centimeters. The researchers will also conduct the experiment in two simulated setups. Specifically, one setup will simulate the classroom environment, and the other setup will simulate the home environment. This will ascertain that the ideal alarming distance in both outdoors and indoors environment shall be the one used and specified in the device.